Assalamu alaikum students, this is Sir Abdul Samad Khan, and today we are going to start our new chapter, that is chapter number 3, logarithms for grade 8, 9 and 10 matriculation. So let's get started. Introduction. Logarithms were introduced by great Muslim mathematician Abu Muhammad Musa al-Khwarizmi. Later on in the 17th century, John Napier developed the concept of the logarithm further and prepared tables for it. In these tables, the base e was used. E is an irrational number whose approximate value is 2.71828 and so on. The properties of the number e were found by great mathematician Euler, so the first letter of his name is used to denote this number. In 1631, Professor Henry Briggs developed the tables with the base 10. This is the brief introduction about the chapter of logarithms. Okay, our first topic we are going to learn is the topic of scientific notations. What are the scientific notations? Scientific notations is a very short way to write very large and very small numbers. For example, like if we see this example, we have given the value 0.000057, and as we know that whenever a value starts from 0, it is the very small value. Okay, so it can be written in the scientific notation as 5.7 times 10 raised to the power of minus 5. Okay, this is how can you write the very small value in the scientific notation. Okay, number 2. Here we have a value with 9 digits like 1, 2, 3, 4, 5, 6, 7, 8 and 9, and it can be written in the scientific notation as 1.2345678 times 10 raised to the power of 8. Okay. If you observe in example number 1, exponent is negative, that is minus 5 over here. And in example number 2, the exponent is positive, that is 8 over here. So now we are going to learn that when the exponent will be positive and when the exponent will be negative. Let us learn when the exponent is taken positive and when negative with the help of some examples. Rules. Rule number 1. Whenever the value starts from any number other than 0, the exponent should always be taken positive, and when any value starts from 0, the exponent is taken negative. This is the first rule. Number 2. In case of negative exponents, you just have to count the number of zeros before and after the decimal. The number of times 0 comes in any value is actually the negative exponent. Number 3. If any value starts from any number other than 0, you just have to count the values before decimal and then less 1 from it. The number of values remaining is actually the positive exponent. For example, like here we have given the value 123.4. So in the above value there are 3 values before the decimal. So if we subtract 1 from 3, we will get positive 2, which is actually the positive exponent. Let us learn this with some examples. Okay, write the following in scientific notations. Now we have given the values in the ordinary form and we have asked to convert it in the scientific notation. So first of all, you need to learn one thing, that whenever an ordinary value you have asked to convert this value in the scientific notation, the point should always be placed after the first value. Okay, this is the scientific notation for this value. And as we learned in the previous slide, that whenever a value starts from any number other than 0, the exponent or the power should always be taken positive. Okay, and the rule is that you just have to count the values before the decimal point and just less 1 from it. So there are 4 values, and when we subtract 1 from it, we will get 3, which is actually the positive exponent. Getting it? Number 2. Over here, this is a very small value, 0.00342, and the scientific notation for this value is somehow like this: 3.42 times 10 raised to the power of minus 3. Why it is minus 3? Because we have seen in the previous slide that whenever a value starts from 0, the power or the exponent will be negative. Okay, and the number of times 0 comes in any value is actually the negative exponent. So there are 3 zeros. 1 0 is before decimal and 2 zeros are after the decimal. So collectively these are the 3 zeros. So negative 3 is the exponent in this case. Number 3, 1 2 3 4, 1234. If we see that in this question we haven't given a decimal point, so you have to remember one thing, that decimal point will give you between the value or before the value, and in this case if we clearly see that the decimal point is not here, that means the decimal point should be at the end of the value, that means after the 4. So the scientific notation for this value will become like this: 1.234 times 10 raised to the power positive 3. Okay ji, definition of logarithms. Let a, b and c are 3 real numbers. If a is equals to b raised to the power of c, then the logarithm of a to base b is c, and it is written as like this: log to base b of a is equals to c. So what does it mean? It means that if we apply power c to base b, we will get the answer a. If we apply power c over the base b, we will get the answer a. Okay, this form is known as the exponential form. The form which is written before this statement is actually known as the exponential form, whereas this form is known as the logarithm form, this one. Okay, let us learn this with the help of some examples. Now, okay, the question is write the following logarithmic form. So the question we have given is in the exponential form, and we have asked to convert it into the logarithmic form. So what we have to do, we have to remember the structure first. The structure is somehow like this. You have to place the base under the logarithm and place the number of which the log you are going to calculate, and the power or the exponent will be shifted on the right hand side. Okay, so this is the logarithmic form for this exponential form. Number 2, in this case if we see 10 is the base, minus 3 is the exponent, and 0.001 is actually the value or the number of which you are going to calculate the logarithm. So similarly, just copy down this method, this procedure, and just put the values over here. This is the log form of this exponential form, that as I have told you, that place the base under the logarithm. In this case base is 10, so we place 10 under the logarithm, number 1, and the exponent will be shifted on the right hand side of the equal to sign. So in this case negative 3 is the exponent, we will shift it on the right hand side, and the number will be placed with the logarithm. So the number in this case is 0.001, so we place it over here. Okay, example number 2, write the following in exponential form. Now we have given the question in the log form. It is the just reverse of the previous one na? So we are going to convert it in the exponential form, and you just need to know one thing: place the base and place the power over it, and on the right hand side of the equal to sign you just have to place that number. Okay, in this case the base is 5, the power or the exponent is 2, and the number is 25. So exponential form in this case will become like this: 5 to the power of 2 is equals to 25. Okay, like in this case the base is 100, the power is 0, and the value is 1. So if we convert it in the exponential form, it will be somehow like this, that you have to place the power over the base, so it will become 100 to the power of 0, and the number will be shifted on the right hand side is equals to 1. So this is the exponential form for this logarithm form. Okay, example number 3. Okay, find the value of x in the following. If we see in this example, we have given three values. One is base, the second one is exponent or the power, and the third one is actually the value of which you are going to calculate the log. Okay, so out of these three, one value is missing. Which one is missing? As I've told you that under the logarithm, base always given, and on the right hand side power is always given. That means we are going to calculate that number or that value. Okay, the same structure we have to follow over here as well, and the structure is somehow like this, as I have told you in the previous slide, that place the exponent or the power over the base and shift that number on the right hand side. So in this case 32 is the base, okay, and the power is -1/5 and the number is x. So if we put the values in this structure, we will get the value like this: 32 in the place of base, -1/5 at the place of exponent, and x on the right hand side at the place of number or value. Number one. Number two is that we have to cancel out these powers. Okay, so for that we have to take the LCM of 32, and when we are going to take the LCM of 32, we know that there are 5 factors of 2 if we take the LCM of 32 by the table of 2. Okay, the fourth step is that this 5 will cancel this 5, and we will have only left with the power -1. Okay, so the rule for the negative exponent is that whenever a value contains a power which is negative or the negative exponent, the value or the base will become a reciprocal. Okay, the numerator will become the denominator and the denominator will become the numerator. In this case, the numerator is 2 and the denominator is 1. So it will become 1/2, and that's the final answer for this question. Okay. Example number 4. Okay, find the value of a in the following. Now in this case, if we see and if we match this question with the previous slide, we will clearly observe that a is actually the base, and we are going to calculate the base in this case. 3 is actually the number, and 1/2 is actually the exponent or the power. So the same structure we will use over here as well. You just have to place these three values in this structure. Base is a, so we are going to place a in the place of base, and the exponent in this case is 1/2, so we have placed it, and 3 is actually the number or the value, so we have placed on the right hand side in place of number or the value. Number 1. Number 2, we have asked to calculate only a, not any power of a, so we have to cancel out these powers. So how can we cancel these power? So you need to know this thing. As we know that 1/2 is actually the power of a square root, and we can cancel the square root by squaring. Since we have to find out the value of a, so we have to square the both sides, and the equation will become somehow like this. Okay, then this 2 will cancel this 2, and we have only left with a on the left hand side, and on the right hand side there is a base and a power. So 3 square will be equal to 9, and that's our final answer for this question. Simple. Okay, the fifth example. Find the value of y in the following. Now in this case the power is missing. Okay, log to the base of 25 of root 5 is equals to y. So we are going to use the same structure. We just have to put the values. The base is 25 in this case, the exponent is y in this case, and the value or the number is under root 5 in this case. So just place the values in this structure. Number 1. Number 2, as we know that if we take the LCM of 25, we will get 2 factors of 5. Okay, so it will become somehow like this. One power is already given over 25, that is y, and 2 is actually the 2 factors of 5 that you get after taking the LCM of 25. Okay, and on the right hand side, as we have discussed in the previous slide, that the power of the square root sign is actually 1/2. So if we just replace this sign, the sign of square root, we will apply the power 1/2. Okay, now we have to learn one new rule. The rule is, now we have to learn a new rule. In such cases, it means in these type of cases, when the bases are same and equal, their powers are also considered as equal, or vice versa. Vice versa means the reverse of the previous statement. Okay, it means that whenever the bases 5 is a base and 5 is a phase, whenever the bases are same and there's an equality sign between them, whenever the bases are same and equal, their powers are also considered as equal. That means we have to just skip the bases and we have to take the powers with the equality sign like this. Okay, this is the rule, you have to remember this. Now finally, as we see that 2 and y are multiplying with each other, so we just have to shift this 2 on the right hand side, and 2 will become divide with this fraction. So 2 times 2 is 4. So our final answer for y is 1/4 in this case. Okay, so that's all from today's video. I hope you all understand this video, and inshallah we'll meet you in the next lecture with some other topics from the chapter of logarithm. Till the next time, thank you so much for watching, and Allah Hafiz.